Welcome back. We are discussing the Lagrange's linear equation. We have already discussed one problem from Lagrange's linear equation using the method of grouping. Now let's see one more example for Lagrange's linear equation and its solution using the method of grouping. Consider the question. Solve y square z divided by x into p plus xzq is equal to y square. Now when we look at the equation, you can see that the equation is of the form p plus q is equal to r. Now we can rewrite the given equation in simplified form as y square zp plus x square into zq is equal to y square x, taking x as LCM. And after that we are cross multiplying that x, so you get y square zp plus x square zq is equal to y square x. Now comparing this equation with p plus q is equal to r, we can write the subsidiary equations are dx divided by p is equal to dy by q is equal to dz by r. So that becomes dx divided by y square z, dy divided by x square z, dz divided by y square x. Now here we are applying the method of grouping. Consider the first two fractions. Dx divided by y square z is equal to dy divided by x square z. Now when we look into the equation, you can see that these two fractions contain z other than x and y. But in this case we can cancel this z so that we can make the fraction in terms of x and y only. So in both sides we have z, so when we cross we can cancel that z on both sides, so you get dx by y square is equal to dy by x square. Now you have to separate the variables, so you can write x square dx is equal to y square dy. Now we can apply the integration. Integrating, we get integral of x square dx is equal to integral y square dy. Now integral of x square dx is x cube by 3. Then integral of y square is y cube by 3. So x cube by 3 is equal to y cube by 3 plus constant of integration is c1. So we can write x cube by 3 minus y cube by 3 is equal to c1. So x cube minus y cube is equal to 3c1. So c1 is a constant, c1 is an arbitrary constant. So 3c1 is an arbitrary constant. So instead of 3c1 we can put an arbitrary constant as a. So we get a solution u of xyz is equal to a, where u of xyz is equal to x cube minus y cube. It need not contain all the variables. Here in this answer z is not there. So even though we write here as u of xyz. So if the variable is not absent, there is no problem. So you can write u of xyz is equal to x cube minus y cube. That's, we take it as equation number 1. So we have to find one more solution for this subsidiary equation which is independent of u. Again, consider the first and third fractions. We can write dx divided by y square z is equal to, only one equal to sign is there, so equal to dz divided by y square x. So here even though this function contains this equation contains the variable y, we can cancel that y on both sides, so we get dx by z is equal to dz by x. Now in this case also we can separate the variables, so we can write x dx is equal to z dz. Now integrating, but we get integral of x dx is equal to integral of z dz. So integrating, we get x square by 2 is equal to z square by 2 plus c2. So we can write it as x square by 2 minus z square by c2 is equal to z square by 2 is equal to c2. Taking 2 as common and cross multiplying it, we get x square minus z square is equal to 2c2, where c2 is an arbitrary constant, so c2 is a constant, so instead of that we can substitute it as b. So we found another set of solution, that is v of xyz is equal to b. where v is x square minus z square. Thus we have got three solutions, two solutions for our subsidiary equation. Hence we have got the solution as we have got two solutions. U is x cube minus y cube and v is x square minus z square. We can say that these are independent of each other. That means we cannot express u as a function of v or v as a function of v. They are independent of each other. So from 1 and 2, the complete solution is function of u comma v is equal to 0, or we can write u is equal to f of v. Therefore our solution is phi of x cube minus y cube comma is x square minus z square is equal to 0. So this is our complete solution for given partial differential equation. Suppose that if you have got the solution, one solution as x cube minus y cube, and we consider the other set of ratios, we get the answer as 3x cube minus 3y cube. So in that case we have to find another set of another solution v, since that two solutions x cube minus y cube and 3x cube minus 3y cube, they are dependent. So one is a multiple of the other, or one is a function of the other. So in that case, if you get other solution in that way, you have to consider other ratios also. So in this problem our solution is phi of x cube minus y cube comma x square minus z square is equal to 0. Now try to solve some problems by yourself. Okay, thank you.